And good morning. I have my webcam turned off this morning because it's early morning and I don't have very good lighting. So anyway, all right, let's go ahead and start. We're going to be in chapter 5 now. So now section 5.1, which is what we're in today, is kind of long and there's kind of a two-parter to it. However, the good news is it's all stuff that you know. If you'll notice, it says revisited. So we're just going over things that we already know, just adding one little concept into it. So you ought to do it pretty well. There are 2 worksheets that go with this one particular lesson, and each worksheet, well, one worksheet is front and back. The other one is just a little bit on the back. So I'm probably going to do it a little bit different than I normally do. So let's go ahead and get started on this. So we are going to be in your book on page, I have no idea, 95. It's the beginning of chapter 5. All right, we're revisiting ratios and proportions. All right, so ratios, as we covered in book 1, a ratio is a fancy name for using division to compare quantities. Ratios can be written different ways. For example, you'll sometimes see them written like this, 3 to 1 is how you say that. However, since fractions represent division, ratios are also written as fractions, as this, 3 to 1. Expressing ratios as fractions makes working with ratios easy, as we already know how to add, subtract, multiply, and divide fractions. All right, so this is showing us the ratio. So here you have 3 cups of flour to every 1 cup of sugar. Now, if you cook, I know you've been here before. Ratio is the relationship found by dividing one quantity by another. So the ratio of flour to sugar is 3 to 1 or 3 to 1. The ratio of sugar to flour is the other way, 1 to 3 or 1 to 3, either way. Sometimes it's helpful to complete the division in a ratio, leaving a whole or a decimal answer too, which we'll go over in just a second. All right, so let's look at this example on the next page. We're going to express 90 over 4, or 90 to 4, as a decimal number. So all you do when you have a fraction to undo it to a decimal, you divide. So it's the same as 90 divided by 4. Okay, 4 goes into 90 22 whole times, which would have 2/4 left over, which is half, so it's 22.5. You know, you're just going to, I'm doing this thinking that you know what I'm talking about, but you may not. So 90 divided by 4. Okay, remember we're making this as a decimal. So 4 goes into 9. Oh, why did I say 8? 2 times, which means we have 8. And then we're left with 10. 4 goes into 10 2 times, minus 8, which gives us 2. But remember, we're making it a decimal. So when we make it into a decimal, we have to add our decimal here. Making sure that's right. Bring a 0 down so we can bring it down. 4 goes into 25 times. So we get 22.5. And there it stops. There, it wouldn't go any further. So that's where they're getting 22.5. All right, let's look at proportions. A proportion is a fancy name for 2 equal ratios. Ratios that are equivalent fractions like these here. Okay, if you could multiply half by a fraction that means 1, like 4/4, because remember this is the same as, yes, I need my notes. 4/4 is the same thing as, is it going to do it? Maybe today? Okay, so 4/4 is the same thing as 1. So if you take a fraction, that's the same thing as 1, 4/4, 8/8, whatever. But in this case, you take 4/4, you multiply it by that, and you're going to get 4/8, which means this is equivalent. Okay, now if you take, and then you can of course draw it out. Here's 1/2, and here is 4/8, and you can just see, you can just physically see that they're the same. So they're equivalent. So this is a proportion. Now this is not a proportion. Okay, you can't, there's nothing that you can multiply half by, no fraction that means 1, where you could get 3/8. So if you multiplied it by 3 over 3, you're going to get 3/6. So this is not a proportion. They're not equal. You can even look at them and tell. Okay? Now, you know how we've been learning in Book 2 about finding unknowns, where we've been using letters with the unknowns. Well, in the past, we've actually done that with our proportions, but those proportions were, they used a question mark instead of a letter. Well, today we're just going to be, rather than using a question mark in those proportions, we're going to be putting a variable in there or a letter. Okay, so here's an example of a proportion word problem. If it takes 1.5 hours to weed 20 square feet of garden space, how long will it take to weed 60 square feet of garden space, assuming you weed at the same rate? All right, since we're weeding at the same rate, the ratio between the time it takes in the garden space we need will stay the same. Thus, we can solve this by setting up a proportion. So it takes 1.5 hours to weed 20 square feet. Okay, this is our first ratio. Okay, and then it says, assuming you go at the same rate, how long would it take to weed 60 square feet? Now, you notice that the top number is the hour, the time. The bottom number is the amount of space. So that means when you set up your other ratio, the other part of the proportion, you've got to put the same numbers where they belong. So the bottom number is the space, because we're given the space, but where we want to find the rate, okay, the time. Okay, so you have to always make sure everything's where it belongs. In other words, it would be wrong if you put 60 up here. It has to stay down here where the amount of space is located. Okay, so we've used x as our variable. Now we need to see what the denominator in the first ratio was multiplied or divided by to reach the denominator in the second ratio. So in order for the ratios to be the same, the numerator will have to be multiplied or divided by the same amount. So if you take 60 and divide it by 20, you know that you get 3. So that means the denominator in the first ratio was multiplied by 3, because we just divided it to kind of undo it. So we know that it was 20 times 3. So whatever happens in the bottom number must happen in the top number. So you're going to multiply it by a fraction that equals 1. And we know that it has to be 3 on the bottom. Therefore, it needs to be 3 on the top to be equal to 1. So we know that 20 times 3 is 60. And now we can say 1.5 times 3 is 4.5. And that's our variable. So it'll take 4.5 hours to weed 60 square feet at the same rate as 1.5 hour per 20 square feet. Okay? Now remember, I didn't remember this when I read through this. I mean, I remember looking over it, but we haven't used it. But there are names to help us refer to the different parts of a proportion. These crossways here are the extremes, and these here are the means. I don't know why we need to know that, but apparently we do. Okay, so that is kind of the first part of the lesson. Remember, we're going over similar shapes now and using proportions with shapes. All right, so let's look at this page right here. So we've got 2 rectangles, okay? Now they're different sizes, but we know they're the same shape. They're both rectangles. So let's look at all of these sides, okay? So here we have this first ratio, the width of rectangle A and the length of rectangle A, okay? So here they've written it down. The width of rectangle A is 2. Is 1. And then the length of it is 1. So they've put their numbers here. Now we're going to take the width of rectangle B, which is 4, and the length of rectangle B, which is 8. Now, if we know these two shapes are similar, then we can set up a proportion to find the length of the missing sides. But this is showing you how these sides are proportional. This right here and this right here are the same number on the different ones. These are the ones that correspond, we say. So the width of rectangle A is here, just as the width of rectangle B is here. So this side and this side are what we call corresponding. They correspond just like this side and this side are also corresponding. All right, so let's look at this example. We have two triangles that are similar. We're going to find the length of the missing side, which is this side here. Okay, so the corresponding triangle gives us all its lengths. The other triangle just gives us 2. So we can know all that in order to find this missing side by setting up a proportion. Okay, so we're going to take 7.5 feet here. Okay, now the corresponding side, well, actually this ratio would be this to this. Now you might say, well, why wasn't it this? Well, it doesn't need to be this because we don't need to find this. This one, this corresponding side is the one we need to find. So that's why we need to use this number in the proportion to find this missing side. If it was this one that was missing, then we'd use this number. So they're setting up the ratio, 7.5 feet to 11.52 feet. Now, these two correspond to these two. So then we're going to set up the ratio like this. Okay, the first one corresponds to this one, so that's why it goes first. And then this one is S, the one with the variable, and it corresponds to this one. So we've set it up that way. Okay, so now you've set up your proportion. Now you just need to solve it. So you need to see what numerator in the first ratio is multiplied or divided by to reach the denominator. So basically you know that 15 divided by 7.5 gives you 2. So you know this was multiplied by 2. So 7.5 times 2 gives you 15. So then whatever happens up here has to happen down here. So multiply both by 2. So you get the missing side then would be 23.04 feet. See how these correspond to each side, and that's how we found the missing side. Okay, now let's look at this page right here. In the previous example, since we knew the triangles were similar, there were a number of different proportions we could have set up to find the length of the missing sides. This is what I was telling you. While we looked at the proportion between the height and the diagonal of each triangle, the first proportion shown below, we could have looked at the proportion between the base and the diagonal of each triangle, at the proportion between the diagonals of both triangles and the bases of both triangles. So basically, here's what we're showing these. So height of triangle A, height of triangle B. These are corresponding sides. The diagonal of triangle A and the diagonal of triangle B. See, that one was the one we didn't know. Okay, so, or we could have gone base of triangle A, base of triangle B, right here. Diagonal of triangle A, which was this, and then the diagonal of triangle B. See how they correspond, and we could have found any of those. Here's another one. The diagonal of triangle A, base of triangle A. Diagonal of triangle B, base of triangle B. So you see how they're the same here, but they correspond to the other one. Now, the point is to remember that the ratio between the sides of each triangle is the same. Then to form a proportion that accurately compares corresponding sides. We could not, for instance, use the proportion below. It's comparing the ratio between the height and the diagonal of one and the ratio between the base and diagonal of the other. See, you've got height and diagonal, and here you have the diagonal, but you don't have height, you have base. So this would be incorrect. They have to be corresponding sides. I hope that makes sense. Okay, as you use math to explore God's creation or help in real-life situations, you'll likely encounter different units of measure. But good news, while the words may change, the principles remain the same. All you need to know is the ratio by which the two units relate, and you can convert from one to another. Remember, dividing a number by itself equals 1. So, since 12 inches and 1 foot both represent the same distance, 12 to 1 and 1 to 12, they're both ratios worth 1. They're the same quantity divided by the same quantity. In this course, we'll refer to a ratio between two units that is worth 1 as a conversion ratio. Conversion ratio shows us how two units compare. We looked in book 1 at 3 different ways to convert between units. They all use the conversion ratio. So I do believe this is the last page today, except for the keeping perspective. So let's look at this. Now this is like the third little section. Now remember, we've learned the 3 different ways to convert, but this is the way that if you look at it, it kind of looks the hardest, but it's actually the easiest. Okay, everybody's very good at converting. Everybody seems to understand it. So the conversion via the ratio shortcut method makes it easy to convert square and cubed units. Don't forget this. So squared would be for like area, cubed would be like for volume. Notice if it's squared, they have to do it twice so that they can account for this subscript, or superscript, I'm sorry. Okay, right here the superscript is a 3. So they have to do it 3 times in order to represent that and mark those out. Okay, don't forget that. So right here you have 12 inches times inches, which is the same as 12 squared inches, times 1 to 12 times 1 to 12. Then you can mark everything out and do the calculations. Here it is cubed. 12 inches times inches times inches, that's cubed. So they have to mark it out 3 times. Okay, so let's look at this. This is just an example of a conversion. Conversion via the ratio shortcut. 500 pounds. I'm sorry, I saw my computer froze. So 2,000 pounds abbreviated with LB equals 1 ton. How many tons is 500 pounds? So 500 pounds times the conversion ratio, which is 1 ton to 2,000 pounds. Remember, what we want is on top, and we want to convert to tons. So then you're going to mark out what you've got, do the calculations, and get your answer. Now, all of your conversion ratios are going to be, I think they're on page 429 in your book with the worksheets. Okay, so you can always use those. You can pull it out, tape it on the wall, you can make a copy of it, whatever you want to do. But throughout this book, you can use that back page. If for some reason you don't have it, let me know, but I think you should have it. So, okay, so now let us look at our pages. Now, like I said, we have, this is 51A, front and back. Then we have 51B, front, and just a little bit on the back. So what we're going to do is, and I'm not gonna do these with you because I feel like these are all just review. So I'm just going to let you do these yourself. Now, right here it tells you the pages. This is not the student book. This is the book that has the worksheets in it. That's known as the teacher book. So it's in the teacher book. Okay, so this just kind of gives you some details here. Now, what I'd like for you to do on this first page, let me look at this one. What I'd like for you to do, I don't want you to have to do every single one of them, but I want you to do some. On the recording ratios, if you want to, you can just do every other one. You are welcome to do them all. If you feel like you need practice, go ahead and do them all. But otherwise, if you feel like you know it pretty well, just do every other one. And I don't care which ones you do. You can do A, skip B, do C, or you can do B, skip C, do D. I don't care, however. But just do every other one here. On the back, I'd like for you to do each one of these. And on the conversions, just do 2 of those. 2 conversions. It might be beneficial too if you write a note on your paper that says, Miss Shelley, you told me on number 2 to do every other one. And then over here, Miss Shelley, on conversions, you said to do 2. Because I may forget. I write these down, but I have a lot of notes to remember. And then on worksheet 5.1b, I'm going to have you, I do want you to do all the back, the skill sharpening. It's pretty simple, so go ahead and do all of 51b. But you can do, and you can do all of both pages if you'd like, but I'm just trying to cut down a little bit on it. Now, if you do make some errors on these over here that I told you you could kind of skip a few, then I may have you go back and do the ones you skipped. But otherwise, make sure you write me a note on there. And remember, I may give you a grade on these pages. I'm not going to write it down just yet as a grade. I think I'm just going to wait and see. But like I said, this is really kind of just a review. So I may give you a grade on it. But let me know if you need any help on anything. I'll be happy to help.